Okay, here's my interpretation of the mark scheme for Foundation Paper 2, November 2012, which is a calculator allowed. So, first question is a bills question. So the first one is pre-filled in for you. And you need to remember that you add that on at the end. That's a very common mistake, is to forget about that one. So we've got 6 times £24.36, which is £146.16. 2 times 43.75, 87, and remember you have to add that 0 and it goes at the end. 3 times £53.52, £160.56, and then the total, so remembering to add the original, 242.68 plus 146.16 plus 87.50 plus 160.56. 636, and again you need to remember to put that 0 in there. And then the 10% discount, 10% you write as if you're writing 10 pence but using pounds, so it would be 0.10 times £636.90, which is already on your calculator, so you're just going to press times and 0.10, £63.69. Then you have to remember to read the question, because this sometimes asks you how much the discount is and how much, or other times how much you have to pay. This is one where you want to know how much the builder has to pay, so you have to take that off. So 636.90, take away 63.69 is 573.21. So the marks for that, you get one for each of the parts of the bill and one for the total, and then you'd have one for the method of this and one for getting the right answer. Okay, question 2. Circle the quantity that is appropriate estimate for each of the following. So the weight of a woman would be kilograms, but it wouldn't be that, because 1,000 kilograms is a ton, so 500 kilograms would be half a ton. Grams is too light, milligrams is even lighter, so we're going for 50 kilograms. The volume of a glass of water, if you remember what I've said, that a normal sort of can of Coke would be 330 milliliters, so it's going to be that one. Height of a man is either going to be in meters, but if you look at the meters available here, is 18 meters, which is unreasonable. You're looking at 2 meters, below 2 meters would be average, so it can't be that one in meters, so we're going to be looking at centimeters, and 100 centimeters in 1 meter, so 200 centimeters would be 2 meters, so that's the sensible estimate there. And then for Calais to Paris, don't know why they keep getting fixated on France with these questions, but they do, and it's kilometers, so it's clearly not those, so it's that one. So you're going to get one for each of those that you get right. Okay, this is a estimating question. The first thing to check is whether there's any scale on the grid. There isn't, so it's just a centimetre squared grid, and you need to show your method. So your method is you count if it's more than half full. Okay, so that's the strategy that you're using, and then if you just dot the ones that you're using. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 45, 16, 17, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 68, 69, 70, 71, 72, 73, 74, 75, 76 is my estimate. Now sometimes they ask you to give the units, they don't this time, it's given for you. Anything there between 72 and 78 is what they're looking for, so that comes in to there. So you need one for your method, which is the dots, that's what they're looking for, and that you are not counting everyone, that you're leaving out the ones that are smaller than a half, and one for an answer within that range. Okay, then we've got a symmetry question. So you use a pencil, you use a ruler, and you deal with the straight line bits first of all. This one's nice because it's already got the mirror lining up with your eye line. So go for the points on the straight line. So there's one there which is 3 this side of the mirror or the symmetry line, so it has to join up with 3 that side. Then leave the curve and work with these straight lines here. So to go from there to there, we got 1, 2, 3, 4, 1, 2, 3, 4. So that one goes to there. Then you have another straight line here, which is 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 away. So join that together. And then deal with the curve. So the curve starts off steeply. So it gets a little bit in there. Then it comes around, so to there, to there, and then across. So what you've got is a line, a curve that's going like that. Okay, it's not perfect, it doesn't have to be, as long as you've got the general gist of it. So you get 1 mark for getting all the straight lines and 1 mark for a reasonable attempt of the curve. Okay, look at the angles A, B and C. Write the letter of the angle alongside its special name. So as I've told you many times, you need to know what an acute angle is. An acute angle is one that's smaller than 90. Acute, it's small, so that is C. Obtuse is a big angle, bigger than 180, sorry, bigger than 90, smaller than 180, so A would be the obtuse, and the right angle is given by the little square box. So if that's a right angle, it's on a straight line, so that must be a right angle as well, because they have to have it at 180. So B is the right angle. So 1 mark for each of those. Alright, so then we've got a tally. So whether you choose to do a tally or count it some other way, I would do a tally myself. So we've got S, U, A, W for season. Then I'm going to tally it, and then I'll total it up afterwards. And as you tally in, mark it off so you know that it's been counted. So I've got S, A, U, W, W, U, S, U, so that's the fifth, so we bunch it. S U W S U A U A S U U S W S W A U A U U A S S U W U. So then you total up, and that's called your frequency, how often it crops up. So we've got 10 for spring, 15 for summer, 8 for autumn, and 7 for winter. Now it tells you in the question that there's 40, so you can check that you've got 40 by adding those up. So you've got 15, 30, 40. So I know that I've done that correctly. So there's 2 marks for correctly doing that, whatever method that you've used. You've then got to draw a graph of that, and what you need to do is use the full, as much of that as you can. So the first thing to do is decide your scale. Now the biggest we need to go up, well, if I get my thing back in here, the biggest distance we need to go up is 15. So see if you've got 15 single squares there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have. So don't complicate it, go up in ones. You need to label your axes, so that axis is frequency. And then you need to plot your bars. Now you've got 4 bars to plot, and really there should be a gap between them. So summer is the first one, which goes up to 10. Followed by, sorry, that's spring, isn't it? Then we've got summer, which goes up to 15. And as I've told you time and time again, use a ruler, a pencil and a ruler for this. Don't use a pen. I am, because it's easier for you to see on the camera. Autumn is 8. And finally winter was 7. So yours should look like that without the smudges. If it is, so there are 2 marks for the correct height and the fact that they're all the same width. So there's 2 marks for correct height. Then you've got 2 marks for the labeling and the scale. Okay, so they won't if those were joined together, you wouldn't be penalized. Okay, the mode is the most frequent. It's one of 3 averages you need to recognize. So the one that comes up most of all, surprise, surprise, is summer. Okay, so the mode isn't 15. The mode is which data is 15, which is summer. An estimate of the probability that a randomly chosen child prefers winter is the number of kids that chose winter, which is 7, out of the total number of possible outcomes, which was 40, because 40 respondents. There were 40 respondents in the survey. So for that you get 1 for the 7 and 1 for the 40. Question 5. Kevin has 10 coloured balls. Some are yellow, some are green and some are pink. He puts 10 balls into a bag, then picks one at random. So your probability is going to be out of 10, which means that that scale is going to be divided into 10. So you'd have 5 there and so on. A is the probability that Kevin picks a pink ball. So how many pink balls are there? 1, 2, 3, 4, 5, 6, 7 pinks. So you're looking for about 7/10 of the way along there. So you'd be looking for somewhere in that region there. Probability that Kevin does not pick a black ball. Well, there aren't any black balls, so it's absolutely certain that he is going to not pick a black ball. So that would be there. And the probability that Kevin picks a green ball is slim, 1 in 10. So that would be roughly there. So you get 1 mark for each of those. Circle the best expression from those given below to describe the chance of the event A occurring. So event A was the probability that Kevin picks a pink ball, and you would say that that is likely. It's not impossible, it's not unlikely, it's not an even chance, because that would be there. It's not certain, so you'd be putting a circle around likely. So you'd have 1 mark for that. Okay, so each row of the following table needs you to show equivalent fractions, decimals and percentages. The first one has been done for you. Now you should know what the decimal for that is, but if for some reason you don't, remember this is a calculator allowed paper, and you can use the calculator, the fraction button, to do the work for you. That's your fraction button. So if you press it, and then if you put a quarter and press equals and then the SD, it will turn it into a decimal for you. And as I said, you should know that one. To turn a decimal into a percentage, you would times it by 100. So 0.6 times 100 is 60%. And to turn a percentage into a fraction, or 60%, means 60 out of 100. So that would be, you could cancel it down, okay, using your fraction key. You could write 60 over 100 and it'll turn it into 3/5 for you, but 60 out of 100 would earn you the marks. In the same way here, 75 out of 100 would earn you the marks. It's not asking you to show the fractions in their simplest form, but sometimes it does. So again, you can use your calculator. 75 over 100 equals 3/4. But in that question, there's no need to do that. So you'd have 1 mark for each of the missing. Two marks for that one. Okay, on to the F questions. Gareth has tiles which are shaped like isosceles triangles. For each tile, the side of the tile that is not equal to the other two has glue on it. The glued side of each tile is the same length. So what we've got, if you think of an isosceles triangle, that side and that side are the same length. That isn't, but it's glued to, it's got glue on it. Gareth takes two identical isosceles triangular shaped tiles, Gareth sticks the two glued sides together so that the two tiles make a quadrilateral shape. So if I've drawn my isosceles triangle like that, then what I've got is that. So I've actually got a four-sided shape with four equal sides, but it's not a square. So if it's not a square and it's got four equal sides, it's a rhombus. Gareth now takes two different isosceles triangular shaped tiles. These tiles are not identical, but their glued sides are the same length. So we're going to do the same thing again now, but where those are the same length, this time that one is of a different length to this one. So we put different things there, and that shape is called a kite. So you'd have one for the sketch, one for the name, one for the sketch, one for the name. Okay, grade E questions. Describe in words a rule for continuing each of the following sequences. Okay, so what is happening to the shape each time? You should see that it's going down in sevens. Now you have to put that into words. Okay, so what you're looking for is to decrease or previous term, subtract 7. Okay, except as I penalised myself there, that's not a word, so you want to subtract 7. Now with this one, what is happening, it isn't being subtracted because we're going positive, negative, positive, negative, positive. So we're going to be multiplying by a negative number to keep that from changing, and it's going to be times negative 2. 2 times negative 2, 2 2's are 4, plus times a minus is a minus, times negative 2, 4 times 2 is 8, minus times a minus is a plus, and so on. So we're going to be multiply previous term or number by negative 2. The sweet weighs W grams. Write down in terms of W the weight of 10 sweets. Okay, so if you remember when I went through this with you, if you're not sure straight away with the algebra, replace the W by a number. So if we say the sweet weighs 5 grams, how heavy would 10 sweets be? 50. 5 lots of 10. So W grams, 10 sweets would be W times 10 or 10W, either of those would be fine. The boy is 6 years older than his brother. One of the boys is X years old. Write down in terms of X the two possible ages of his brother. So if the youngest is X, so if the youngest is 10, the oldest is 16, which would be 10 plus 6. The other X plus 6. If the oldest is X, so if the oldest was 10, the other brother would be 4. Would be 10 take away 6, X take away 6. So one of them is X take 6, one is X plus 6. So it's a bit nasty. You've got to do both of those to get the 1 mark, and there's no half marks. So 4/9 of 45. Often this comes up on a non-calculator paper, so you would find 1/9 by doing 45 divided by 9 and then multiply that by 4. But it's on a calculator paper, so you can just use your calculator. 4/9, 4/9, and then of means times. So what you're doing on your calculator is 4/9 times 45. Oops. Which is 20. Given that 5w equals 2p plus 3r, find the value of p. Okay, so we've got to put in what we know. We know w. Now remember, in algebra, if there's no sign, no mathematical symbol between a letter and a number, there's a times there, but we don't put it in because it'll get confused with an x. But as soon as you replace the letters, you have to put that in. So it's going to be 5 times 4 equals 2, don't know what p is, plus 3 times -4. Work out what you can. 5 times 4 is 20. Still don't know anything about 2p. Plus times a minus, or plus times a negative, is -12. So what we've got then is an equation. We need to find out what p is. We have to get rid of the take 12. Doing that by doing the opposite of taking 12, which is adding 12. If you add 12 to one side, you have to add it to the other as well. So 12 is gone from there now, because -12 add 12 is 0, but that becomes 32 equals 2p. Now we can deal with the 2 that's attached to the p. As I said, if there's no sign there, it's a times. So that's a times 2. So we can do the opposite of timesing by 2, which is dividing by 2. If you divide one side by 2, you've got to divide the other side by 2 as well. In algebra, 32 divided by 2 is written like that, and 32 divided by 2 is 16. So for that one, 1 mark for previous term, take 7. 1 mark for multiply previous term by -2 or -2. That one is 1 mark. 1 mark for both of those. For C, any method you use is fine, including using the calculator. And for this one, you get 1 for correctly substituting in. Then you get 1 for getting down to 2p is 32, and 1 for working p out to be 16. And then there's a final part to that question as well. So it's another equation to solve. You need to get rid of the add 3, take 3 off both sides. Take 3 off that and you get 18. Now you've got to deal with it times 4. Opposite times of 4, divide 4. You've got to divide both sides by 4. Now you can simplify that, or you can leave it as it is. Actually, no, you can't. Just curious. You've got to work it out, which is 9/2 which is 4.5. The reason I was pausing then is I'm looking at the actual exam mark scheme, and they wouldn't accept 9/2, which is really strange. Anyway, so you've got to work that one out to be 4.5 or 4.5. 1 mark for 4x is 18, 1 mark for 4.5. Okay, exchange rates. As I've said many times, there's 2 parts to an exchange rate question usually. First part is straightforward, you're going from pounds into, and then part B you're going backwards. So Toby's gone to China, he's changed £700 when the exchange rate was 1 to 9.79. So for every pound he's got, he gets 9.79 Chinese yuan. So yuan, sorry. So 700 lots of 9.79. So he gets 6853 CNY. Whilst on holiday, he went on a tour which cost that much yuan. What was the cost of the tour in pounds? So this is where you're going backwards. So rather than multiplying, you can do the opposite to turn it back into pounds. So you're going to do 2447.50 divided by 9.79. £250. So 1 mark for the method, 1 mark for the answer. 1 mark for the method, 1 mark for the answer. Okay, on to the D's. Number sequences can be created by choosing a starting number and a step number. For example, if a starting number is 20 and the step number is 5, then the sequence would be 20, 25, 30 and so on. Write down the next 3 numbers of a sequence where the starting number is 10 and it's going up in sevens. So the next one will be 10 add 7, which is 17. The next one will be 17 add 7, which is 24. And the next one would be 24 add 7, which is 31. A sequence can have negative steps. Write down the next 3 numbers of a sequence when the starting number is 35 and the step number is -4. So it's going down, taking off 4s. So it's going to be 35, it's going to be 31, it's going to be 27. 27 take away 4 is 23. 23 take away 4 is 19. A sequence is a starting number of 40 and a step number of 6. By considering the difference between 140, explain how you can decide whether or not the sequence will show the number 100 at some stage. So it's got to move through the numbers from 40 to 100, which is 60. If 60 was divided into 6, if that goes, it gives you a whole number, it will fit in. If it was going up in sevens, 7 doesn't divide into 60, so it wouldn't work. So it's got a distance of 60 to cover. When you divide that by 6, it's 10. So yes, divisible by 6. So 100 will be in sequence. 2 pupils, John and Megan, play a game together. They each make up a sequence by independently choosing a starting number and a step number. The choices are in the following table. After how many steps will they show the same number at the same time, and what is that number? So if we go up with John, going 30, 39, 48, 57, 66. Let's see if Megan gets there yet. So 40, 47, 54, 61, 68, not there yet. 68 and 7 is 75. 66 and 9 is 75 as well. So 75 is the number after 1, 2, 3, 4, 5 steps. After 5 steps, they are both on 75. So marks for that. One for that. One for that. C is 2 for showing what the difference is, and that it does divide by 6. And for this one, it's 1 mark for after 5 steps and 1 mark of 75 for 75. They decide to find out, without writing down the sequence, if they can predict whether or not their sequence will show the same number at the same time as they did in part D. They choose the following starting numbers and step patterns. So if I put John's here and Megan's here, John starts at 9 and Megan starts at 53. The difference between those two starting points, 53 take 9, is 44. We then add 12 to John's, so he's on 21. We add 8 to Megan's, so she's on 61. The difference between those two is 40. We then, for John, we're going to add 12, so that's 33. For Meg's, it's 61 add 8 is 69. 69 take away 33 is 36. So what's happening here is, as these numbers are getting larger, the difference between them is getting smaller and is going down by the same amount each time. So we know that that difference is going to end up at 0. So they will be on the same number at the same time. So we've just got to explain that now. So I'm saying the difference between the numbers in the sequences is decreasing by 4 each time. So we'll get to 0 where both numbers will be the same. So we don't have to write the whole list, we're just looking to see how the gap is closing. And because it's constantly 4, if it was 1, then 3, then 7 or something, you couldn't guarantee that, but we know that's going down in 4s and it is going to end up at 0. That's quite a tricky one. So 1 for your method, 1 for the answer. Question 11. Be assessed on the quality of your written communication in this question. So you've got to explain what you're doing. ABC is an equilateral triangle. So that side, and that side are the same length. Okay, so we're going to write that down. Equilateral triangle has all equal length sides, and this is the important bit, each angle is 60 degrees. So I know that that bit and that are 60. Now, the angle that I need to work out here is ACE. It's all of that. Now, the other thing that I'm being told is BCDE. BCDE is a square. So if BCDE is a square, then I know that that is at 90 degrees, and that diagonal is going to cut it in half. So that there is going to be 45 degrees. So BCE equals 45 degrees because diagonal line cuts the right angle in half. So angle ACE is going to be 60 plus 45, which is 105 degrees. So you've got to go out of your way to explain that you know what's special about an equilateral triangle, and the fact that you know, well, if it's a square, they're 90-degree angles, and that is going to cut that one in half. So for that, you are going to get 1 mark for each of the angles. So 1 mark for the 60, 1 for the 45, and 1 for the 105. And then your explanation is the words that you've surrounded them with. Using a ruler and a compass, bisect the angle given below. So an angle bisector, you take the compass, you put the point of the compass on the corner of the angle that you want to cut in half, open it out any particular length, keep it sensible, don't go huge or tiny, and then take your compass point where those 2 compass marks cross the lines. Don't change the size. Draw another arc, then move the compass point to the other side, draw another arc. Now those are what the examiner is looking for, so do not rub them out. And then you join the angle through where the compass crosses. So that bisects the angle. If they don't see those compass marks, you're not going to get any credit for it. So what you get there is 1 mark for those, 1 mark for the second and the line, and then X looks to me to be halfway. So it's 4.9, sorry, it's 3.9 that side, 3.9 that side, so you're looking for perpendicular bisector. So again, you can't just use a protractor and measure it. So you get your compass, you open it out more than halfway, you draw an arc above and an arc below. Then without changing your compass, you put the point on B and you do the same again. So your arcs look like that, and then you join through your crossing. That's a perpendicular bisector. Again, you'll get a mark for the compass, 1 for the line, but without the compass you won't get any work, you won't get any marks. Okay, so I'll stop there and then we'll come back and do the last